Rockets are some of the most powerful vehicles in the world, capable of reaching speeds of up to Mach 20, about 8 kilometers per second, and carrying large amounts of material into orbit or even beyond into the solar system. They are incredibly complex machines that showcase the peak of engineering and aerospace technology. But what is the most simple rocket you can make? In this series, I'll explain how rockets work and build multiple different complexities of rocket in a rocket building simulator. I'll cover almost everything from small simple rockets like Robert Goddard's Nell liquid-fueled rocket to the biggest space launchers like the Saturn V, which sent people to the moon, and even ahead to future rocket technologies. The simplest rocket design consists of a tube filled with propellant, usually a mix of fuel, like potassium nitrate, and an oxidizer. When the fuel is ignited, it burns and produces heat and gas. This gas has to escape somewhere, so it's forced out of the rocket's nozzle. The expulsion of the gas creates thrust, which pushes the rocket upwards. This is explained by Newton's third law of motion, which states, for every action there is an equal and opposite reaction. The gas is expelled backwards and the rocket is pushed forward, lifting off the ground. I'll now design my own rocket using a rocket building simulator. This software lets me adjust parameters, like fuel type, nozzle design, weight, and shape to see how they affect its flight. This is the most simple rocket setup available. It is used widely in things like fireworks and hobby rocket motors, and it's no more than a tube with a hole at the bottom, attached to a stick. So, let's see how well it does. Launching of the tube on a stick in 3, 2, 1... That did quite well for just a tube on a stick. Let's see how we can improve this design and make it go farther. To improve on this design, we need to add more fuel and make the craft more aerodynamic by adding a nose cone. Now let's see how this new and improved rocket design will work. Rocket 1 got to an altitude of 1,900 feet. Rocket 2 got to an altitude of nearly 11 kilometers. This shows us that even small differences in the rocket's design can cause huge differences in the rocket's performance in flight. Anyway, that's it for this video. I hope you enjoyed it, and stick around because I'll be making some more stuff soon. Goodbye.